Episode 6, Large Language Models, LLMs, and Natural Language Processing, NLP. Hello everyone. Welcome back to our beginner-friendly AI learning series. Today we're diving into natural language processing, NLP, and large language models, LLMs. You've probably interacted with these without even realizing it. Think about talking to Siri, Alexa, Google Translate, or even getting suggestions while typing an email. How do these tools understand and respond to us in human language? That's exactly what NLP and LLMs are all about. In this episode, we'll break down what NLP is, how LLMs work, and see some real-world examples. Let's jump in and unpack these concepts together. Explanation of NLP. First, what is NLP? Natural language processing is a branch of AI that teaches computers to understand our human language, both the words we write and the words we say. In simple terms, NLP is the ability of a computer program to understand human language as it's spoken or written. Imagine you're teaching a friend a new language. You explain vocabulary, grammar, and context. NLP does something similar, but with programs. It's like giving computers a giant language textbook and lots of examples, so they can figure out meaning and context. NLP is everywhere around us. For example, when you talk to a virtual assistant like Siri or Alexa, NLP is what lets it understand your voice command and figure out how to respond. It's also behind tools like Google Translate, turning text from one language to another, spell checkers that correct your grammar, or email apps that suggest how to reply to a message. In other words, NLP helps computers make sense of words and sentences so they can answer questions, translate languages, spot spam emails, summarize articles, and more. You can think of NLP like a translator or interpreter between human language and computer language. Just as a translator learns the rules and vocabulary of languages, NLP systems use algorithms to dissect sentences into parts, recognize patterns, and assign meaning. For instance, NLP might break a sentence into words. We call that tokenization, tag each word's role, like noun or verb, and analyze the context to figure out the overall meaning. But don't worry about the technical steps. The key idea is that NLP gives computers a brain for language, so they can handle tasks that involve reading or listening like we do. To summarize, NLP is all about helping computers read, listen, and respond in human language. It's a core technology behind things like chatbots, virtual assistants, translation apps, and many other tools. In the next sections, we'll see how large language models fit into this picture and make these applications even smarter. Introduction to LLMs. Now let's talk about large language models, or LLMs. An LLM is a special kind of AI program designed to work with language. To understand the name itself, let's break it down. Large, it means that the model is trained on massive amounts of text data, which helps it learn diverse patterns and understand language deeply. Think of it as having read an entire library compared to just a single book. Language, it focuses on human languages, like English, Spanish, or any other natural language, rather than programming languages or other types of data. Model, in AI, a model is a program that has been trained to recognize patterns and make predictions. In this case, it predicts how to generate human-like text based on given input. In a nutshell, LLMs are like extremely knowledgeable language experts who have learned from vast amounts of text data. They can generate text, answer questions, and understand human language in a way that seems remarkably human-like. In more technical terms, LLMs are a category of foundation models trained on immense amounts of data, making them capable of understanding and generating natural language. In plain words, these models learn patterns in language by analyzing vast text sources. A good example is OpenAI's GPT-3, which was trained on hundreds of billions of words. In fact, GPT-3 has 175 billion parameters, which you can think of as internal settings that the model adjusts while learning. Each parameter helps the model capture a tiny piece of information about language. Because there are so many parameters, LLMs can hold incredibly rich knowledge about how words and sentences flow. Why large and why model? The model part just means it's a mathematical program, often a type of deep neural network, that makes predictions. Large highlights that it uses enormous text data and many parameters. For example, imagine trying to write a book with only a tiny phrase book versus having the entire library of a university at your disposal. That's the difference between a small language model and a large one. In a nutshell, LLMs are designed to understand and generate text like a human, based on the massive amount of data used to train them. They learn grammar, facts, and even some reasoning simply by being exposed to so much language. During training, the model sees sentences and figures out which words tend to follow others. It's like training a kid by reading them thousands of stories. Eventually the kid gets so good at the language that they can tell stories of their own. LLMs do the same with mathematical precision. A helpful analogy: think of an LLM as a super smart friend who has read virtually everything on the internet. If you start a sentence, this friend can almost magically guess how you might finish it, because they've seen so many examples of language. Or imagine a chef who has learned millions of recipes and can whip up a new dish by mixing ideas. Similarly, an LLM blends patterns from its training text to generate new, coherent sentences. Some popular examples of LLMs you might have heard of are ChatGPT, GPT-4, Google's Bard, and Meta's Llama. These are all systems built on the same idea: train on a huge corpus of text, then use that knowledge to chat with you, answer questions, write text, and more. They often use a technology called the transformer under the hood, which helps them focus on different parts of a sentence, what we call attention, but we don't need to dive into that detail right now. The big takeaway: LLMs are like giant textbooks turned into a smart program. Once trained, they can do many things with language, from answering questions to writing essays to translating languages. Thanks to their size and design, they capture a lot of nuanced information. For example, they can figure out context clues, the bank by the river vs bank where you save money, handle slang or different styles, and keep track of a conversation in context. How LLMs understand and generate text. Alright, now that we know what LLMs are, let's explain how they actually work in everyday terms. At a very high level, LLMs go through two main stages. 1. Training on text. First, the LLM is fed a massive amount of text, think billions of web pages, books, articles. During this phase, the model learns about language by processing examples. Specifically, it learns to predict the next word in a sentence. For example, given the cat sat on the _____, it should guess mat. Over many trillions of such examples, it figures out the patterns of grammar, word meanings, and even some facts. In this way, it learns vocabulary and how sentences are put together. Each time it makes a prediction, it adjusts its internal settings, parameters, to get better and better. This is like reading a huge corpus of stories and slowly piecing together the rules of language. IBM explains that LLMs are trained on billions of pages of text to learn grammar, semantics, and relationships between concepts. So during training, the model is really just learning by doing, constantly guessing and correcting. 2. Predicting and generating. After training, the model can generate text. How? You give it a prompt or a starting sentence, and then it predicts the next word, then the next, and so on, until it forms a complete answer or story. This is often called autoregressive generation. Because it has learned from so much text, its guesses are surprisingly good and contextually relevant. Essentially, for any input you give, the LLM looks at the words and context you provided and chooses the most likely next word. It then adds that word and repeats the process, building a sentence or paragraph. The result is that it can produce coherent, human-like responses. To make it even simpler, imagine playing a game of Mad Libs or fill in the blank. You give the LLM the first part of a sentence and it fills in the blanks one word at a time. But unlike a simple autocomplete on your phone, an LLM considers the whole history of the conversation or text so far. It's like having a supercharged autocomplete that can write entire paragraphs or even songs. Here's an analogy to tie it all together. Think of an LLM as an extremely powerful version of the predictive text you see on your smartphone. When you type a message, your phone might suggest the next word or emoji. An LLM does that too, but on steroids. It looks at your prompt, which could be a question or a few paragraphs, and then continues writing in a natural way. Because it has read so much during training, it can handle creative writing, solve problems, or chat with you in a pretty intelligent way. We should also mention context. LLMs keep track of the conversation. If you say "tell me about Paris," it knows from its training that you might mean the city in France, and it can recall that context if you follow up with "what about the Eiffel Tower?" This memory of previous words is thanks to the way the model is built, its attention mechanism, but at our level we just think of it as keeping track of what's going on. In short, the LLM process is training, read a ton of text to learn the rules of language. Generation, given a prompt, predict next words one at a time to produce a response. These predictions are what make the text sound human-like. And because the model has such a large brain, billions of parameters, it can combine knowledge and style to write about almost any topic. For example, if you ask it to write a story, it'll use patterns it learned from reading lots of stories. If you ask a question, it'll formulate an answer based on similar questions it saw during training. Here, remember, the LLM doesn't know things in the human sense, but it has seen so many examples that it can mimic knowledge. Sometimes it even makes mistakes or hallucinates incorrect info. That can happen because it's based on patterns, not actual understanding. But overall, this next word prediction trick is what powers all the impressive text it generates. Real-world applications. So, what can we actually do with NLP and LLMs in the real world? The answer is, lots of things that involve human language. Let's look at some popular examples and applications. Chatbots and virtual assistants. Think Siri, Alexa, Google Assistant, or customer support chatbots. These use NLP to understand your request, play music or what's the weather, and often use an LLM-like model to formulate a natural response. For instance, when you ask a digital assistant a question, NLP techniques parse your speech into text, and then the AI picks an answer to say back. IBM notes that LLMs are increasingly used to power conversational AI, making these interactions more natural and context-aware. In business, many companies use chatbots on websites that can answer FAQs or help you navigate services, all thanks to NLP at the core. Writing and content creation. There are now tools that help you write emails, articles, social media posts, and more with the help of AI. For example, some email programs can suggest whole reply sentences based on the content of a message. LLMs can draft blog posts, summarize a long article into a short paragraph, or even write poems and stories on demand. IBM explains that text generation by LLMs is used to write emails, blog posts, and other content when given prompts. This makes them handy as writing assistants or content ideation tools. Translation and summarization. NLP powers translation apps like Google Translate, which lets you convert text from English to Spanish, or many other languages, quickly. LLMs also excel at summarizing long documents. If you give an LLM a long article or report, it can produce a concise summary in seconds. Oracle's explanation even mentions summarization as an NLP tool. So if you've ever seen an AI that can give you a quick digest of an article or a transcript, that's NLP in action. Coding assistants. Surprisingly, LLMs are also great at helping with computer programming. Tools like GitHub Copilot or other code generators use LLMs to auto-complete code, find bugs, or translate ideas into code. IBM points out that LLMs can assist developers by writing code snippets, debugging, or translating between programming languages. For instance, you might describe a function in plain English and the AI writes the function code for you. This is NLP, understanding your request, combined with language modeling, generating code text. Search and analysis. Search engines use NLP to improve results. When you type a query, NLP helps understand synonyms and context. For example, if you search for automobile, NLP can match pages that say car. NLP is behind spam email filters, detecting unwanted language patterns, and sentiment analysis, figuring out if a review is positive or negative. Many businesses use NLP to scan customer feedback, analyze trends, or even organize large collections of documents by topic. In healthcare and law, NLP helps sift through medical records or legal contracts to find key information. Here's a quick bullet list summary of these applications. Chatbots and virtual assistants, apps that answer questions in real time, Siri, Alexa, website chatbots. Writing and content tools, AI writers and editors that draft emails, posts, or summaries for you. Translation and summarization, instant language translation, e.g. English to Spanish, and condensing long texts into short overviews. Coding assistants, programming helpers that generate or explain code snippets. Each of these examples uses the core idea of NLP, or LLMs, understanding human language input and generating useful, human-like output. Finally, let's use one more analogy for applications. Imagine you have a very smart robot assistant who reads everything on the internet. You can ask it to chat, write, translate, or analyze text, and it will use what it learned to help you. That's how LLM-powered applications feel, versatile and surprisingly helpful in many language tasks. And that wraps up episode 7. Today we learned that NLP is all about teaching computers to understand and work with our language, and LLMs are the giant AI models that make sense of language by training on huge text data sets. We saw how LLMs predict next words to generate human-like text, and how this powers everything from Siri to smart writing tools and translation apps. If you enjoyed this explanation, please give us a thumbs up and consider subscribing to keep learning about AI with us. We've got more episodes in this series coming up, and you won't want to miss them. Hit the notification bell so you know when the next episode is out. Thanks for watching, and we'll see you in the next episode of our AI learning course.